Hello everyone, thanks for joining my channel Cloud and Coffee with Navneet. Are you struggling to decide whether to buy a home or continue renting? Trust me, you're not alone. The buy versus rent debate has never been more challenging, especially in US, where home prices have surged over 40% in last 5 years. Mortgage interest rate have fluctuated, impacting affordability, and rent prices have increased by 20% in many cities. With so many variables, how do you make an informed decision? Trust me, I've been there. When I was buying my home, I spent countless hours watching buy versus rent videos, reading articles, and crunching numbers. Yet, the decision felt so overwhelming. Traditional advice often feels generic and doesn't consider your personal financial situation or the local market trend. What if GenAI could simplify this decision for you? Imagine having a GenAI powered tool that analyzes your specific market data, test different financial scenarios, and give you personalized recommendation based on the real number, not just on the gut feel. That's exactly what we are building today. But before I can show you how you can build it, let's start with the demo. Cool, so let's see how this works. So first thing we need to enter is the zip code. I've been entering this 10001. And again, this zip code is coming from the sample data set, which is there. Let me show you the sample data set in very first place. Okay, this is the source. This is yeah. So here is our sample data set. This is where I will be providing the zip code, property price, monthly rent, interest rate, tax rate, property type, etc. So you can able to provide similar kind of a data on your area as well. So this way model able to go and analyze on this data itself. Okay. So I've been providing the zip code. I have provided first what will be the price here. Let's say make it $1 million. Okay, and what will be the monthly rent? Maybe you can trying to find out, okay, what's the monthly rent for this same house if you have to rent, and then maybe you can provide the interest rate here. Thereafter, what you're looking to do is like buy versus like how does the loan term look like for you. So it will be 15-year or 30-year, and you can include other like 10-year and 7-year as well, but here just for this demo I will be just showcasing 15 and 30-year, and thereafter you will be providing the property tax. And this is where it get interesting. I will be telling like, okay, how much I have for the down payment. I have $1 million, so default you should be going with the 20%. Let's say if I do not have a 20%, I only have this 150k, and then how much I'm able to afford. So monthly rent is 6,000, my affordability is just 5,000. Okay, so now let's go and analyze it. So if as I said, like in traditional AI, I just put analyze and start will giving me answer, whereas in the reasoning model it takes some time into some thinking, it collect all the data, run some number, and then provide you output. So we have to wait for it to get it. It usually takes somewhere around 30 seconds before it will provide you answer, and we'll wait for it. Cool. So now we got our response here. So if you see here, this was AI was thinking, let me analyze the buy versus rent decision based on the data provided. First, I will calculate the key metrics. So it will be calculating the key metrics. Here I'm having this $1 million, and then I'm having this 150 as a down payment. This much I need to get a loan for, and then I have interest rate of this much. This is the term. I will be using the simple formula here, and then once we're done with the formula, we will be getting this much of a principal and interest as a monthly payment. Thereafter, I will be having the house tax, which is 1.2% of it, and then like monthly tax this much. Thereafter, well, this is the property tax. Thereafter, it will be calculating the insurance, estimating is the 5% annually. Then maintenance will be the 1% of the house, and the total ownership of the total cost of ownership is coming around 7,684. Thereafter, it's telling this monthly rent of 6,000, and then this is 5,000. I am able to do that. Opportunity cost for down payment. If I invest that into S&P, I will be getting the 8%, the moderate return, right? I will be getting this much of return in next 30 year, right? 1.5. I think it's a 1.5 million approx. Now it's going and making a decision. I really like this comparative table analysis. It will be telling me like, okay, property price this one, this one I will be paying this much of monthly cost. This is there. I will be having 2,684 as an above, and then this is like 1,000 because I have a affordability of 5,000, right? So down payment I will be paying this much, none. Home equity over 5 years this much, I have 0 equity. And then property appreciation after 3 years this much, and then here is no appreciation. Investment opportunity none because I will be paying as a down payment. And here if I could have invested into S&P 500, this much of return I could have been getting. Thereafter maintenance cost, right, this is covered by landlord. Flexibility of course not. And then tax benefit. So this is what is coming down, like time-based recommendation. Short term 1.3, this much, right? And then medium 4 to 10, and thereafter long term. And what's the final recommendation? Final recommendation is buy as a rent, because affordability concern, as I said, like we are only have a 5,000, and current market condition, the higher interest rate makes buying particularly expensive right now. Financial flexibility, of course, it will be providing renting preserve like 150,000, which we have this as a capital. And then of course strategic positioning. By renting now, you could be potentially saving for the last down payment, wait for the interest rate and decrease. And here, right, I will recommend reassessing situation. If interest rate drop below 5%, your income increase better off this much of, and then you can make a large down payment, reduce the mortgage payment. So yeah, this is so really interesting, right? So it went through everything, and then it will providing you recommendation based on reasoning, just not a simple simple output. With that, this is our demo. Let's learn how you can able to build this solution. So hope you like the demo, and you will be interested to learn how we can able to build this one. And that's what we're exactly looking to do. In this video, I will show you how you can create a buy versus rent decision advisor using Claude 3.7 hybrid reasoning model on Amazon Bedrock. This Gen AI powered solution doesn't just crunch number, it thinks through the decision logically, as I shown you an example, just like a real estate expert would. You can take this knowledge and apply it to other decision making scenarios. What you will be learning in this video, you will be learn how to input your own real estate data, how AI can stimulate different financial scenarios, and how you can get a structured data driven recommendation. And trust me, if you get stuck anywhere while setting this up, don't worry. You can simply ask any LLM. That's what I use when I was troubleshooting and when I was building this one. Or you can able to open a issue on my GitHub repo, or if you want, you can just simply comment on my YouTube channel, and I'm able to on this video, and I'll try to help you there. Okay. To make things easier, I have divided this tutorial into sections. The first one is demo, which we have already seen how the buy versus rent model look like. Now I will going to walk you through the architecture overview. Once we're done with an architecture overview, I can able to go and show you the code deployment, and I will walk you through what all things are there in the code. Okay, hope that makes sense. So let's start with an architecture. So step one, like this, where the user provided input in the Streamlit application, where the user start with entering key details like zip code, home prices, rent, interest rate, tax, down payment, and how much they're able to afford for the rent in the Streamlit UI. The next step is the input which is provided by user is processed by the app.py, which kind of format the data and call our AI logic. The next step is we are looking to analyze. So in this one, we will be using this analyze.py file, which kind of prepared a structured prompt and sent to our Amazon Bedrock. And here in Amazon Bedrock, that's where the magic happened. Amazon Bedrock invoke Claude 3.7 hybrid reasoning model, which deeply analyze the data using the built-in thinking log feature. And at the end, like the Claude 3.7 process all the information and provide short-term, medium-term, long-term financial insight. And finally, the model determine whether buying or renting is the better decision based on all the financial factor, right? So and once we're done, like it will be also providing the final recommendation and displaying us, hey, this is my final recommendation whether I should be buying or renting, and then also giving me reasoning behind coming to the final reason. And as I showed you in the demo, it was displayed in the Streamlit UI, right? So that's how our buy versus rent decision model works, and this architecture seamlessly integrate user input, AI powered reasoning, and financial insight to provide the data driven recommendation. And if in the architecture we have learned some keywords like in a reasoning model, Amazon Bedrock. So let's go and double down on those terms. So what is reasoning model? A reasoning model is an advanced AI system that thinks through the problem step by step and before providing an answer. Unlike simple AI model that just retrieve information, reasoning model break down complex decisions logically and constructually. So the next logical question come in mind is why we are using reasoning model in our buy versus rent use case. So if we start going with traditional chat or traditional model or chatbot, right, it give you the answer quickly, but the major financial decision like you need to buy a home require logical explanation, financial modeling, and in-depth analysis. Let me give you a scenario. So if I just ask in a demo I showed you, right, I was asking, hey, whether I should be buying or renting on the zip code 1001. A simple AI might say, hey, buying is a better because value increase over the period of time. But reasoning model, it went through into multiple steps, right? It calculated our monthly mortgage, it calculated how much rent we able to pay it. It has put those number across. If we are looking to invest our down payment to S&P 500, how that can be, that can turn out over the period of time. Also the equity of your home, right? And then comparing and just telling whether you should be buying or renting, and then also kind of give you what's the ratio of the renting versus buying look like, and then eventually tell you, hey, you should be wait for a lower interest rate before you even thinking to buy a house in that very particular zip code. So if again it went through that logical explanation, it did the financial modeling, and then provided this analysis. Other things which we have learned is we will be sending, everything is running under the Amazon Bedrock. So let's understand what is Amazon Bedrock is. Amazon Bedrock is fully managed AI service by AWS that provide access to the foundation models from the multiple providers via an easy to use API. It allow developers to build and scale GenAI applications. It allow to have access to the powerful LLM without managing the infrastructures, and also it allow you to do a fine tuning of those models, put guardrails around those models, able to build the agentic solutions, etc. So it's kind of entire managed offering by AWS to work on the LLMs, right? So now let's go into the code. So let me explain how this is gonna work. So we will be using 3 code. So even before we go and what we are building, let's understand how we're gonna make this work. So we will be using three core components. One is Amazon Bedrock, which allow us to run the Claude 3.7 AI model or hybrid reasoning AI model. We will be using Python for the backend processing and API call, and then we are using the Streamlit to create an interactive web UI. For this video, to keep it short, I do not I will be not explaining the Streamlit process, how that can be done. I will be just going and explaining that Amazon Bedrock code to you. So this way you will be having understanding what we are doing, and this simply you can able to clone my Git and use the rest of the file as it is without you being worrying about making any changes at all, and then it will be run for you. Okay, so let's start set up our environment and install everything we need. I will highly recommend to use Python virtual environment. So the first step is we are looking to go and clone the repository. So you will be using the git clone and then provide the path of my repository, and once done, just go and into cd to the folder buy or rent decision. Once done, the next step is we are looking to go and install the requirements. So once you're done installing the requirement, the next step is you will be looking to go and configure the AWS credentials. So here I will be skipping that configuring the AWS credential, but you can find many videos within the YouTube that kind of guide you how you can able to configure your AWS credentials, but you will be using AWS configure and then providing the profile. Here keep in that mind, the profile which I'm looking to use is called Bedrock, but you can able to replace that with any other profile, maybe the default profile or any other profile you wanted to have this one. So once we have this step, once this setup is up and running, now you're ready to run your AI model. It is as easy as it is. The only thing is like you have to go and update the ARN of your Claude 3.7 model. That's it. Once done, you can literally go and use it. But I can go and explain how this Claude 3.7 model works. So this way you can have a fair understanding of how I have created that analysis piece of the code, right? So let's go and learn how that analysis piece of the code works. So now let's break down how Claude 3.7 hybrid reasoning model processing the data to make the informed decision. So when we interact with AI model like Claude 3.7, we need to guide them how to think and respond. That's where the system prompt and user prompts comes in. So system prompt, think of it as an AI role and mindset. It set the overall behavior of model. In our case, we tell Claude, hey, you are a highly analytical real estate advisor, provide a structured data-driven analysis. This ensures that AI stay focused on the logical reasoning and provide well-structured insight. Let's understand the user prompt. So this is an actual question or task we give to the AI. For example, given buying or renting is a better financial decision based on the considerations. So the user prompt include real estate price, mortgage rate, down payment, rent cost, S&P growth, your etc. Right? So Claude can process the data and make informed decision. Now again, the next logical questions come in mind is why we are using them, because system prompt let AI stay on track with a clear role, and user prompt it process specific request with the relevant details, which eventually help us to get structured, accurate, and relevant responses. So by carefully designing this prompt, we ensure Claude 3.7 hybrid reasoning model effectively provides meaningful real estate advice to us. So now let's break down the key part of our code, the payload we send to the Amazon Bedrock, interact with the Claude 3.7 model. So payload is like a package that contains all the instructions and the data we want the AI to process. Let's go through step by step. The first one is entropic version. This tells Amazon Bedrock which version of Claude we are using. In this case, we will be using Claude 3.7 model, which is running on Bedrock. Other one is the system. This sets the AI role, instruct it to act like a highly analytical real estate advisor, ensuring structure and logical reasoning. The next one is message. Here we send out user query, the actual real estate data and the question, should I buy or rent? This information Claude will analyze. Max token. This defines the maximum response length. More token means longer and more detailed answer, with a fewer token limit AI risk. Temperature. This controls how creative and precise the AI model should be. Since we enable thinking mode, the temperature is set to 1, allowing model to deeply reason through the problem. Thinking. This is where the real magic happens. Thinking modes allow Claude to analyze, compare, and reason step by step before giving an answer. Budget token 1024 means Claude get up to 1024 tokens to internally process its reasoning before getting the final recommendation for us. In a simple term, this payload structure our request to Claude 3.7 can analyze market data, think through the different factors, and provide well-reasoned buy versus rent decision. So now that we have built our payload, it's time to send to Amazon Bedrock and get our AI powered decision. The first one is the response. This line called Amazon Bedrock, asking it to process our request using Claude 3.7 model. Model ID. This specifies which AI model we want to use. In our case, we will be using Claude 3.7 running on Amazon Bedrock. So you need to go and get the ARN for your Claude 3.7. The next step is the content type. Since we are sending structured data in a JSON format, we specify the content type is JSON. Except here we tell Amazon Bedrock that we accept the response in JSON format as well. Body. Finally, we take our payload, which contain our system prompt, user query, and AI reasoning settings, and convert into a JSON format string before sending it to the Bedrock. In a simple term, this command acts like a request to the Bedrock, asking Claude 3.7 to analyze real estate market data and return an intelligent buy versus rent recommendation for us. So if I have to summarize this entire piece of code, what it do, so it reads the AI market data, it reasons through the different factors like mortgage cost, rent, long-term gains, etc. And eventually at the end, it provides a structured response with the final recommendation. So we're going to run the analysis for zip code. In this case, we are looking to have an example for 1001. This is a New York related zip code. So I will be going into Python. I will be going into the source folder, and then I will be running this analysis 10001, and then it will be going and executing it. Py, we're going to run it for zip code 1001, and so here AI will be generating recommendation for this particular zip code, and I have provided this predefined number, right, around all these parameters. So based on this parameter, it will be providing the recommendation for us. So it will be AI thinking, like it will be evaluating your mortgage rate, mortgage cost, best financial decision for us. So now let's see how you can able to run this as a web app on your local machine. For that, we will be looking to use something called Streamlit. So you can able to go into our source folder and look for this app.py. It's very easy. You can go through this entire code and see how that is being done. I will be not gonna go and explain in this one, but you can able to simply use the Streamlit run source and \app.py to run this command, and then it will be open a web UI for you. Have to go and click on analysis, and that's it. Then this is being done, right? So there you have, right? You have successfully built this AI powered buy versus rent decision advisor. As I said, like, I've been using sample data in this use case, but you can able to provide your own data as well, and then you will be able to work on the real time the data set. If you like my video, please do like, subscribe, and share with your friends. And thank you very much. Looking forward to see you in the next video. Take care.